So I thought I'd walk through some of the components within the AC section of this controller board and just call out various part numbers for people who are interested in that. So here, starting on the left, this little gray terminal block is an end block, and it has a little screw in the front, and it basically just locks itself onto the DIN rail. And so it's used to sandwich the other components together and keep things from moving. All of the terminal blocks I'll be calling out in my controller board are all from a company called Phoenix Contact. So if you look up these part numbers, you'll be able to find out what they are. So this is 800-886, which is a Phoenix Contact part number. So anyway, moving on, the next up is this grounding block. So these are colored yellowish green kind of mix. And the important thing about this part is that there's two little metal hooks that touch the DIN rail, and so they essentially make an electrical connection with whatever wires you're putting in. They make continuity with the DIN rail, which then makes continuity with the back plate and the chassis of your machine. And so you can't really interchange these, even though they look very similar to, say, these red or black terminals. They're very different in that regard because they're making continuity with the chassis of your machine. And so pretty important difference there. Next up is this Rotary Disconnect. So this is a SOMEC. So these tend to get rated by current, and it's just, you can just think of it as a gigantic switch. So this is actuated from the outside of my enclosure, and it just turns on and off power to the entire machine. So basically the power from the wall comes directly into this Rotary Disconnect first. And we'll get into that later. But anyway, it's just a disconnect. So next up is the main circuit breaker. So this is a two-pole circuit breaker. The two poles are bound together, so if one side pops, the other one does as well. And this is an Eaton, and it's a 30 amp and has a C tripping curve. So basically there's B, C, and D, which are the most common tripping curves, and C is just a little more permissive. It's meant for inductive loads, like starting large motors that might have a large current draw on startup and things like that. Next up is these red terminals. So these are just through terminal blocks, so it just connects one side to the other, and these are three sort of bound together, and they're bound using that little blue bar, which is a bridge. So I just wanted to make this a little clearer. So here's a little animation of these blocks. So the terminal blocks go together, and then this bridge goes in and binds them together. And so here's the black ones coming together, and then they get bridged together. So it's a pretty important and common feature of these terminal blocks to understand. And so the reason I chose, blue was just to make it more obvious to anyone looking into the box that those three terminal blocks are bound together. So it just basically means visually and continuity-wise is that all the wires that are coming into that red block, all three of them, are connected together. And so that's what that bridge does. Next up is this power supply. So this is a Rhino brand. I think that's the house brand for Automation Direct. And it's a little 60-watt DC power supply. So it takes 240-volt AC and makes a little bit of 24-volt DC. And that runs through the latching circuit, which is controlling this contactor, and going through the various e-stop switches. And so that's the next component, which is the contactor here. And so this is a Fuji one. Once again, these tend to be rated by how much current they can interrupt. So you can just view it as a sort of big relay. So there's a 24-volt DC coil inside, and that's what's actuating whether this contactor is closed or open. And then they're rated on how much current, basically. When you have a lot of current and you're trying to break that circuit open, you need a certain rating. So anyway, next here is on the side of it, mounted to it, and it has a little finger that sort of reaches in, it's an auxiliary contact. And so it's also made by the same manufacturer. They usually will go together. And this has a normally open pair of connections and a normally closed. So basically, anytime the contactor changes state from open to closed, it takes this auxiliary contact with it. And so since two of the connections here on the auxiliary contact are normally open, so they basically just close, and then the normally closed ones open. So you can use that to signal, and in my case, they are participating in the latching circuit, which we'll get into later. All right, next up is just the black terminals, pretty much identical component to the other one. And in this case, it has a red bridge, but basically does the same thing here. And then next, we have two-pole circuit breakers. And so one of these will be going to the DC power supply and the other to the VFD. And sandwiched between them, it's a little hard to see there, but I tried to highlight it, is an auxiliary contact. And so it's the same principle as the auxiliary contact on the contactor, but this one is bound to the VFD's breaker. And so this is, we'll talk about it later, but it's basically, I need a way to communicate to the controller board if the circuit breaker for the VFD would ever to blow. And so let's say the VFD overcurrents, the circuit breaker opens, then we're going to tell the controller board that has happened so it can stop motion, because it would be horrible if your spindle stopped and you just kept on plowing it or trying to plow it through your workpiece. And so that's what that auxiliary contact is for here. So let's walk through the electrical connections of this section of the controller board. So this is Fusion 360, and I've downloaded most of these drawings of the components from the internet. Two of the things that are conspicuously missing are the auxiliary contact for the contactor and the auxiliary contact for the VFD's circuit breaker. But it shouldn't matter too much. We'll talk about those in more detail when we talk about the latching circuit that controls the contactor in a separate video. So the first thing that happens is that the power comes in from the plug, which we plug into the wall. And I'm in North America, so this is split phase AC. And this plug is 240 volt AC 30 amp. So this is a 3-wire, and so we have 2 hot wires and 1 ground. And so there is no neutral. And so the first thing that happens is that ground wire is bound to the ground terminal block. And it's super critical that this happen first, and that this ground wire not go through a rotary disconnect or any other kind of switch. It needs to be constantly in contact with the chassis ground of your enclosure. It's a safety feature. The idea being that if you ever have a bad connection or other fault and mains power is somehow energizing the enclosure, that the current will find its way back to your panel through this ground wire rather than through your body or anything else in the shop. And so it's really important that this connection be good. And so it's, from a safety standpoint, it's probably the most important connection in the entire box. So next, the 2 hot wires go straight into the rotary disconnect. And when this rotary disconnect is open, this is as far as the power goes. Nothing else downstream gets powered at all. So the rotary disconnects come with this rod, which can be cut to any length you need. And then that rod is inserted. And there's actually a little nut which allows you to secure this rod inside there so it won't come out. And then on the door where the actual switch is, it just mates with it. So when you close the door, you're then able to turn on the power of the machine. And so when it's on, that locks in there, and if that bar is locked, then the door will not open. And so it's a safety feature for the electrician, so that they know that if the door is openable, then the power is off. And so I've configured my machine so that the bar can actually withdraw, and so that is not enforced. And so if we turn on and thus close the rotary disconnect, power then is fed to the circuit breaker right next to it. This is a 30 amp circuit breaker with a C tripping curve, and this just mimics the rating of the circuit breaker at the panel in my house. And hopefully this one's a bit better quality, so it's just here as an added piece of safety. And so when that circuit breaker is closed, power is fed to the distribution bus right next to it. And so this bus feeds items that need to be powered all the time. And in my case, there's just 3 items. It's the 24 volt DC power supply, which is right next to it, that controls the latching circuit that runs the contactor. And the Stego enclosure fan, which moves air to cool everything in the enclosure. And then lastly, the ammeters that are on the front panel. And I chose to include those 2 items here because I wanted both a visual and auditory reminder of when power was being energized within the enclosure. And so out of this distribution block, we're taking power to this 24 volt DC power supply. This power supply gets its own ground wire going back to the terminal block. And then out of the same distribution block, power is going directly into the contactor. And so basically all the power that is consumed by this, the stepper motors, the controller board, and the VFD come through these 2 wires. And so this is what is being basically switched on and off when the contactor is either energized or not. And so when the contactor is closed, meaning it's energized, then power flows to this next distribution block. And so this block is downstream of the contactor, so its power is thus interrupted. It basically is controlled by the contactor. And so in my case, this enclosure is just these 2 items. It basically power is fed out of here to the 2 circuit breakers. One is powering the main linear DC power supply, which powers all of the stepper motors and the controller board and things like that. And then the VFD itself. And basically the wires going out go to the VFD and to the power supply. So here at the machine, the first thing we do is we turn on the rotary disconnect, and we hear the Stego fans coming on. We also see the ammeters come alive. And then on the next, then we hit the actual switch, which is part of the latching circuit, turns on the contactor, and that powers the rest of the machine. So here we have an indicator. That's the temperature sensor for my Gecko drives, and the VFD is now online. You also heard the stepper motors power up. And so essentially, if we look inside, one of the things you'll be able to see is if I turn off that switch by hitting the red button, the contactor will open. So that's the contactor moving. Now I'll turn the power back on. So that the coil, which is a 24 volt DC coil in there, is being activated. It's pulling that contact in and basically turning on the power to the rest of that circuit. So that's it for this video. I think the next one will actually go through the latching circuit. It's kind of complicated, but pretty important feature of these controller boxes. So anyway, thanks for watching.